Okay, for a function, this is 84.b. Very, very important concept. Thankfully, it's not a really complex one, but it's a basic concept of a function is a function is something that has a function has input. You plug something in, and you get something out. You make fun of my students. Make fun of the fact that I'm students. Okay. So a function is something that you plug something in and you get something out. That's the basic idea. And the main rule for functions is this here. Every input has one and only one output. So if I plug something in, is it okay for nothing to come out?
No, that's impossible.
No. Let's say I've got some function. I'm going to use this fancy looking tab here. Let's say that I plug in
green. Green.
Let's say that I plug in. Let's say I plug in a 2. Let's say I plug in a 2 and I get a 4. As far as you know, is this actually a function? I plug in a 2 and I got a 4.
Yes.
Okay. Let's say I plug in a 3 and I get a 6. Does that sound like a function?
Yeah.
Okay. Let's say I plug in a 4 and I get out an 8.
Yes.
Okay. Yes, let's connect those. All right. Let's say that I plug in. Let's say I plug in an X, and I get out, and I get back a 2X. Is that still okay? Does that
totally.
meet this? Does that still
Every
fit?
input has one and only. Yes.
Okay.
Yes.
What happens
correct.
if I plug in a 2 again, and this time I get a 5?
No, it's supposed to be a 4.
Yeah.
Silly.
Right. Whatever is happening here, whatever this is, if I plug in the same input and I get 2 different outputs, it's not a function.
Exactly.
So in order to be a function, every input has to have one and only one output. So plugging in a 2 and getting a 4, and plugging a 2 in again and getting a 5, that is not acceptable.
Not acceptable.
Right? What happens if I plug in a 5 and I get nothing?
Then it's not a function.
That's not acceptable. That's not a function.
Not acceptable.
Now, based on these inputs and those outputs, do you think you can give me a pretty good guess as to what the function is or what the function does?
2. Multiply.
What this particular function is doing is it's taking whatever I plug in, it's multiplying it by 2, and then giving me something back out.
I have a question.
Yes.
What if, can it if it's like a 2, but could it take away?
Sure. The function can do different things.
Okay, so it doesn't have to just add or multiply. It can add on certain.
Add, subtract, multiply, divide, square root. I mean, there's all kinds of things you can do. What we're doing now is instead of focusing on what a specific function is saying in general a function does these things or it has these characteristics. You plug something in, you get something out. All right. So what lesson 84 is trying to show you is emphasize this point, this idea here, that every input has one and only one output. That's a key idea right there. Now, there are different ways to draw or write or represent visually a function. This is one. This representation is called a function machine, or a lot of people call it a function machine. You draw a box and you have an arrow showing something being plugged in, and an arrow showing what the output is. In this particular example here, what was happening inside here is that it took whatever you plugged in and multiplied it by 2, and then gave you the corresponding output. So the way I would write the description of this function is that the name of the function is f. So I would say the f of x is 2 times x. So whatever, because what it is here, what's going on here is we are taking, these here are the inputs. These are kind of like your x. And with these, we're plugging in the inputs. The function is doing something to it. And then what we get over here, what comes out, the outputs, is kind of like the y. F of x equals 2x is another way of saying y equals 2x. Those are two different ways of expressing the same idea. So typically, whenever you see f of x written like this, this is f of x is how we read that. F of x and y typically usually mean the same thing. So associate in your mind, associate f of x with y. And that could also help give you an idea here. Now, connecting this to another idea that we have covered in the past is the idea of domain. Right? We talked about domain a little bit. Domain is this stuff over here. Domain is all possible inputs. And then I don't remember if we covered this specifically or not, but the outputs, all the possible outputs, are called the range.
I like the other range better.
Okay. If it help, one thing that helps me remember which is which, on the left, we have our domain with our inputs, also known as x. On the right, we have our range with our outputs and our y. Notice that regardless of whether you say left and right, domain and range, input, output, or x or y, they're all in alphabetical order. That's one of the things that helps me remember which is which. Left, right, domain, range, input, output, x, y.
Can you write that down?
That might be helpful, actually. Yes, actually. While you're writing that down, you might also write this down. You don't need to know this right away, but just write it down for now. Because in the same way, horizontal and vertical. When we graph things, our x-axis is horizontal and our y-axis is vertical. Horizontal and vertical is also the same alphabetical order. We're not graphing these things yet, but I imagine we will before too long. So there's, so this type of drawing is called a function machine. You have inputs on the left, outputs on the right. If you look on page 347, there are some other ways. Other ways to draw it is just with ovals and arrows, not using a box. So at the top of page 347, we've got an oval on the left that has a 4 and a 2, and we have an oval on the right that has a 3, and then we have arrows from the 4 to the 3 and from the 2 to the 3. What this is saying is, left, right, main, range, input, output. That for this example here, if I plug in a 4, I get a 3. If I plug in a 2, I get a 3. For this criteria here, does this represent a function? Does every input have one and only one output? Right? A 4 gives us a 3, so it has an output. And plugging in a 4 again is only going to give you the 3 again. So the 4 has one and only one output. The 2 has one and only one output. This is a function. Take a look at the upper right corner. Left bubble has 4, 2, and 1. 4, 2, and 1. So this one is a function. Yes. The next bubble to the right.
So are we just saying at this point what if they are and are not a function?
The main thing we need to worry about is whether something is a function.
So we don't really solve like you did for that one up there? We don't need to solve?
Not for now.
Okay, good.
All right. With this pair of ovals, I plug in a 4, I get a 3. I plug in a 2, I get a 5. I plug in a 1, I get a 6. Does this meet the criteria to be a function?
Yep.
No.
Yeah.
Does every input
Yes.
have one and only one output?
Yeah.
Oh, no.
Yes. So this is also a function.
Wait,
In the left, I have a 4.
and there's
You don't have to figure out what happens.
Yeah, you know.
For an input of 4, is there one and only one output?
Yep.
Yes.
Yep.
For an input of 2, is there one and only one output?
Yep.
Yes. For an input of 1, is there one and only one output?
Yep.
Yes. Now, by contrast, let me show you something that would not be a function. Let's say we have a bubble over here on the left, and 3, 5, 6 is a big bubble on the right. And let's say the arrows go like this.
Interesting.
That's not a function.
No.
That's not possible.
If I plug in a 2, I'm going to get a 6. If I plug in a 4, I might get a 3 or I might get a 5.
that's.
It's not.
Wait,
So this is not a function.
yeah, I get that one, but is that one's a function? No, the one about it. That one is?
Yes.
Okay, so it does have one.
Yeah.
So notice the difference here. Notice the difference. Different inputs could have the same output, but you can't have one input having more than one output. So what you might want to write down
I
But that
uh,
doesn't.
having two different inputs give you an output. That's okay. However, if you have one input that goes to two different outputs,
Okay.
that's not a function.
I get it. I was.
Yeah.
lost.
Well, it's a good question because that's part of what the homework problems are gonna have. They're gonna have something like this and something like that. So you just need to know which is which.
Yeah, I was looking at the homework problem when I read the question.
Okay. So this is another way to visually represent functions. An oval with the inputs and an oval with the outputs and then arrows connecting them. One more way to do that, and then I think I'm done. Look at page 348 real quick. The last pair of circles, it has like this. It has a circle on the left and it just says all real numbers. And then it has an arrow that says y equals x plus 2, and then a circle over here. So in the example 84.8, it says, okay, these are all the things that you may plug in. This is what happens to it, and then you'll get outputs. What's going on in that whole thing? Does this describe a function?
No.
Is this rule going to give every input one and only one output?
No.
No, I forgot how I worded my question.
No.
If I take any real number and then I add 2 to it, am I going to get the same thing answer every time for the same input?
No. You're
No.
boy.
I know, I'm just so stuffed up.
What happened?
So this is a function. You can do it this way too. The problem could tell you what all the possible inputs are, and it could give you what the rule is, and
Why not?
that's still okay.
Okay.
All right, pause the video or stop the video for a second. Okay. All right, there's another way to represent a function. Instead of having 2 ovals with arrows, which takes up a lot of space, then we can do it another way here. So if we do, remember the one that had 4, 2, and 3 over here with an arrow like this and an arrow like this?
Yeah.
If you remember that on the left is our domain, those are inputs, those that correspond with the x. And on the right we have the range, that's our outputs, that's our y. 4 and 3, if we think of that as an ordered pair, 4, 3. This represents plugging in a 4 and getting a 3. And this represents plugging in a 2 and getting a 3. So this function, and we determined that this was the function because every input has one and only one output. This function and this function are 2 ways to represent the same thing. So this one was a function. If we, one of the other examples that we did, 3, 5, 6, one of the other examples that we did that had this and this and this, if I were to write this as ordered pairs,
So,
this one had
4 and 3. Oh, okay.
this one had plugging in a 4 and getting a 3, plugging in a 4 and getting a 5, plugging in a 2 and getting a 6.
Yeah. Okay.
So the key here, when it's in this form, it is okay to have 2 things on the left, or different things on the left, pointing to the same thing on the right. That is okay. So having different numbers in the x position for the input and the same for the output, that is okay. However, what's not okay is to have the same number input have 2 different numbers for the output.
Oh.
So this is how you can tell what's okay and what's not a function with the arrows. When we're talking about ordered pairs, if we're talking about ordered pairs,
Wait.
uh,
Oh, no. Wait, that's not a function.
if we have the same, oh, wait a second.
No.
If we have a different x and the same y, that's okay. Here.
Oh.
All right, so we're talking about ordered pairs in this form. In x, y. It's okay if you have a different x with the same y. However, it is not okay to have for the same x to have different y's.
Okay.
So take a look at example 84.a or 84.9, letter A. Are there any x's that have a different y with them?
Yeah.
Yeah, there's 4, 6, and 4, 5.
So that's not a function.
That's not okay. So in 84.9, letter A, that is not a function. How about letter B? Are there any x's that have different y's? In 84.9, problem B. The inputs are 4, 15, and 11. So it doesn't even list the same input. There are no same inputs, so that one is a function. That one's okay. All right, top of the next page, 84.10, letter A. Are there any? Is that one a function? 84.10, letter A. Look at the inputs first. What are the inputs?
1, 2, 3.
1, 2, 3, and
It's
4.
a function.
Okay, so it only lists each input once. So that one is a function.
Oh.
Yep.
That was good. That was
Example
perfect.
84.10, letter B.
1,
The
2,
inputs
Oh.
are 1, 2, 1, 4.
1 and 3.
So since you have the same input, you have to check the outputs. It has one ordered pair that says 1, 2, and another one that says 1, 3.
1, 3 can't go.
You can't have 1, 2, and 1, 3. That's not a function.
Oh, so you did both of those? Well, then you just.
Now take a look at letter C. The inputs are 4, 2, 4, 3. So it lists an input of 4 twice. But what's the output? 3, both times. Right? It only, letter C, it only shows you an input of 2. It says that you plug in a 2, you get a 2. That's the only time it talks about plugging in a 2. So that's fine. It talks about plugging in a 3 and you get a 3. It only talks about plugging in a 3 once. So that's fine. It talks about plugging in a 4 twice. But both times it says that your output is 3.
So it's fine.
So that's still fine.
Both
To,
times.
to do that, if I did that one in this style, 84.10 letter C, we've got 4, 2, 4, 3. There, 4. That was kind of like doing this. So the letter C problem, you plug in a 4, you get a 3. You plug in a 2, you get a 2. You plug in a 4, you get a 3. Plug in a 3, you get a 3. That's okay, because for the same input, we got the same output.
Oh.
So that does meet the criteria that it has one and only one output. Just because you say it twice doesn't mean it's different. Yes.
Do we have to show our work like that? Do we have to
No.
make one of those?
No. All right, take a look at letter D. Function or not a function?
Not a function. Right.
Okay, why not? What's the,
Because it's 1 goes to -1, 4 goes to -1, and -1 goes to -1. Right?
is that okay?
Yes. Wait.
Yeah.
Is it possible for a 4, a 1, and a 4 and a -1 all to go to -1?
Yeah.
Oh.
Yeah, that's okay. You can have the same y, that's okay. You can have different x's with the same y.
Okay.
You just can't have the same x with different y's.
Oh, so that is a function.
Yeah.